Hi guys, welcome back to my channel Programming with Pirai. In today's video, we are going to see about a question called bottom view of binary tree. So they will give a binary tree and we want to give what is the bottom view. And see here, if I was seeing from the bottom, okay, I'm seeing in bottom, then what are the nodes is visible to me. So that should be my output. Okay, if I see from bottom, it is like what? It is in a vertical line, right? It is in a vertical line. So I can see this 25, yes, and then I can see this 15. Whether I can see this 22? No, because this 15 will block that 22, right? Okay, if I see here, here there are 3 and 4 are at same position. So what should I take? They also give one a condition like later if formed should be considered if multiple node exists. So this is the condition they are given. So what is the later if formed node? It is 4, right? Because first 3 is formed, then only 4 is formed from this, right? So we want to output our 4 as our output. Now here they can see this 10 is visible, yes, but this 8 is blocked by 10, right? This 8 is blocked by 10. Now here that's only one node, so 5 is visible. So I can say 5, 10, 4, 15, 25. So this is my result. So you want to return this. So this question is simple, right? Okay, let me draw a line like this. So this line says that my root is at 0. So whichever in my left of my root is what? A minus 1. And here it is my plus 1. Here it is minus 2. Here it is plus 2. It is like an XY coordinate. I just built what? An XY coordinate. And just observe this. Carefully. Whatever the node that dot at last in this each line, that should be my answer, right? So we can see this in this case in last, but first, see here, whatever the element that dot at last in each level, that means in each lines, that should be my answer, right? 5, 10, 15, 25. So that should be my answer, right? So from this, I can say, we want to just take the last node into our some data structure to give the result in these lines. So we can do BFS traversal such that whenever we go to the left side, we will take what? Do the minus 1. Whenever we go to the right side, we do what? A plus 1. Simple. And take what is the recent value and update once more. Can you understand this? Because we want the last level element, right? This is the last level element in this line minus 2. And this is the last level element in dot minus 1. So we are going what? A BFS traversal. So how to do is, so see here. This is my initial tree, right? Now, I'm going to do a BFS traversal. So, to do the lava traversal, we want what? A queue data structure. Now, inside this queue data structure, what else I need? I need whether it is at the 0th line or minus 1 line or 1 line, right? So, I want that. And also, I want this root as another parameter, right? So, I put what? 20, 0. So, it indicates what? 20 is a node. And it is lying at what? It is lying at the 0th line. It's lying at the 0th line. So this is my first queue element. Other than that, there is no more, right? So first of all, I will pop it out. Okay, now I will pop it out. Okay. Now while popping it out, I want to store this in some data set, right? So I use a hasmap. So that this hasmap will store what is the element in this line 0 and what is the element or what is the node we have chosen in line minus 1. What is the element we have chosen in line minus 2, like that. So it is what? Line 0. So put it 0. And what is the value? It is 20. So put here. Simple. Now, this level is finished. Now we are going to the next level. So after popping this 20, what should we do? We should add the children's, right? So 20 and 22. Yes, no. I will pop this 8 again, right? This 8 again. Okay. What are the child of this 8? I can say 5, 3 are the child of this 8. And also, sorry, I forgot to put the configuration. See here, when I am adding this 8 as a child, I want to put what? 8, I'm going towards what? A left side. Whenever I am going to a left side, do minus 1. Whenever I am going to the right side, do what? A plus 1, right? So, 0 minus 1, it is minus 1. So, put like this. Okay, then, whenever I am just taking the right side, right? While taking the right side, what should I do? I should plus 1. So, put 22 and do what? Plus 1. So, 0 plus 1 is 1. Can you understand this? Okay, now, it's time to pop out. So, pop this out. Okay, 8. Now, what are the child of this 8? Left child is 5. So, initially what is my value? -1. So -1 it is -2. So put the 5 and do what? A -2. Yes. Then put the 3 and do what? As 0. Can you understand this? Okay. Now this 8 is at what? At a -1 line. So put -1 and put what? 8 here. Can you understand this? Can you understand this? Yes. Now again I will pop this 22 again. Okay, what are the child of this 22? I can say the child of this 22 is 4 first of all in the left side. Okay, put 4 and put 0 here. Yes, then what is the right child? It is 25, right? So I can say this one, and then plus 1. So because of 25, right? So it is equal to 2. So I will put 25, comma, 2 here. And also this 22 lies in what? Lies in the first line. So 1 and value is what? This 22. Can you understand this? Yes. Now I will pop this 5 outside. Okay. Now this 5 have any children? No. Okay. What is the line? It is -2. So -2 is what? 5. Right? Now again I will pop this 3 again. This 3 again. So what is the value? What is the line of this 3? I can say that 3's line is 0. So I want to update my 20 as what? 3 now. Want to update my 20 as what? 3 now. Why? Because I want to take the last or recent levels value, right? I don't want the 0th level value, but still I want what? I want the second level value, right? The second level value. That's why I'm taking what? This 3 as our 0th line answer, right? Again, what are the children of this 3? I can say 10 is a children, right? Okay, 10 is what? Left children. So if it is left children, do -1. So 0 minus 1 is -1. Fine. Now again, now it's time to pop this 4 out. Okay, I'm popping this 4 out. While popping this 4 out, what should I take? So this 4 is what? At the 0th line. So update it. Then what is the children of this 4? I can say there is only one children, which is a right side. So I should do what? +1. So 0 plus 1 is 1. So 4 comma 1. Hope you understand this. Now I want to pop this 25, right? Okay. What is the line of this 25? It is 2, right? Okay. So 2 is not in this dictionary. So I will put 2 and 25. Now whether I have any children? No. So don't update it. So now popping this 10 outside. Okay. Now this 10 has what? A line of -1. So -1 is updated as what? 10 now. Can you understand this? And 10 doesn't have any children, so don't update it. Now I want to pop this 4 outside, right? Okay, I'm popping this 4 outside. Okay. This 4 is at what? At level. Sorry, this should be what? 15, right? Because 4 is right side, right? Sorry, this is 15 only. So I'm popping this 15 outside. So this 15 is what? At the level 1. So sorry, at the line 1. So I will update this 1 as what? 15. No, this 15 doesn't have any child. So stop here. Because the queue become what? Queue become empty. Queue become empty. So we should stop here. Can you understand this? Okay, now by seeing this, I can say these are going to be an answer, right? Okay. How should we arrange this answer? First, it should be what? -2. Then this should be -1. Then 0. Then 1. Then 2. So such that my answer should be like what? First of all, -2. -2 is what? 5. Then -1. -1 is what? 10. Then 0 is what? 4. Then then 1 is what? 1 is 15. And 2 is what? 25. So this should be my answer. Can you understand this? Okay. So how can I print it? We can take the maximum in this dictionary and minimum in this dictionary. This key. So what is the minimum key? It is -2. What is the maximum key? It is 2. So I want to traverse this, right? We can do this while doing this BFS traverse. Okay, I will tell you in the code. And what is the time and space complexity for this approach? I can say my time complexity going to be O of n because I'm just traversing each and every node. And space complexity will be what? The maximum among all levels. Maximum node in each level among all levels. See here I have how many elements? Here I have 4 nodes here, right? 4 nodes are observed here. So I can say 4 is the maximum space I required while using this queue.data, right? So what is my space? It will be 4. Can you understand this? That's why my space complexity is what? Maximum node in which level. So that's my space complexity. Now let us see the code. See here, this is the code. First of all, I'm taking a dictionary. Now q is equal to actually root is what? Root is 0. Okay, and root comma 0. I put root and also the position of it, which means what? The line, right? Now start comma end is what? Start I kept as what? Float of infinity, and end is what? Float of minus infinity, which means what? Int max and int min. I will tell you why these are used. See here, while I have queue data set, then what should I do? While I have some elements in the queue, I should do what? Node command line is equal to just queue.pop of 0. So I then what? I just store the node in node and the line number in this line. Okay, now d of line is equal to node.data. I just updated it, right? I just updated it. Okay, now if node.left, then what should I do? I should take the left child and also do what? Line minus 1. If it is 0, I should take what? A minus 1 there. Can I understand this? Okay, now if node.right, then I do what? A plus 1 and append those tuple here. Now start is equal to minimum of line comma start. So I can say start is the minimum point in that dictionary key, right? So I keep track on that minimum, and end is equal to maximum of line comma end. Can you understand this what I have done here, right? Now result is equal to list. Now for I in range of start to end plus 1, and if I is in dictionary, then what should I do? Just take that as our result, right? Can you understand this? I should take that as in my result, that value, that keys corresponding values in my result. Now return this the result. Let me submit it. Yes, it is submitted successfully. Now see here, you might think instead of giving this, I can give like return d.value. But in Python, the dictionary values, the key value pair is not in ordered way. In C++, it is what? We have an ordered map, a separate data structure. But in Python, we don't have that. So when I compile this here, see here, what is the output? It is 132 is a output that I got, but actual output is what? 312. Can you understand this? I got what? The 0 first, then I gone to the left side. So left second, then I gone to the right side. So right as the third. So dictionary doesn't sort any values. It just keep the values in the order we just insert them. Right? That's why we don't use this this method. Instead of this, you should take the minimum value and maximum value and iterate to this and take the values separately. Okay? Thank you.
It's the other dot nom.
Yes, the minute.